Okay, no, but I'm discussing how to do this, how to name this thing. So you don't have to write this down because you know it already. We've already done this before. These are your 6 polyatomic ions that I told you come up very frequently. You have to be able to recognize them. There is one positive polyatomic ion, NH4+, which is a cation, that could also be in part of a compound, and that's ammonium. These are on table E. Okay? The problem is you're not going to know when to look on table E, so recognizing them helps. So let's go back to LiSO4. Do you see that it has 3 elements in it?
Yes.
The next thing you're looking for, does it contain a polyatomic ion? Does it contain one of these? Yes, it does. Say yes, it does. And it's right here. That's the sulfate. So now when we go to name this thing, we're going to name the lithium. And then the second part, the anion part, is going to be sulfate. So this is lithium sulfate. You always have a first name and a last name. The first name is the cation, the last name is the anion. What about this guy? What's NH4? Ammonium. And you've got the anion right here. Chloride. Ammonium chloride. What about that one? Magnesium phosphate. You have to recognize your polyatomic ions. Here's one. Does it have a polyatomic ion in it? No, it doesn't have a polyatomic ion. This compound right here, although it's ternary, it doesn't contain a polyatomic ion, so it does not contain an ionic bond. It is all covalent. Carbon, hydrogen, and oxygen are all covalently bonded. If you go back to this magnesium phosphate for a second, okay, the magnesium phosphate contains both ionic and covalent bonds. Let's talk about where they are. The ionic bond is going to be between the cation. Let's highlight the cation again. That's the positive. And the anion, which is the negative. So there is a ionic bond right here between the magnesium and the phosphate. The covalent bond, let's take orange. The covalent bond, maybe not take orange, is going to be between the phosphorus and the oxygen. Right, Mr. Valerio?
Right, always.
You're looking a little different than you did before.
Yeah, I took it off.
It was too hot, right?
The wig, like, real and everything. Yeah. It's too hot. I was Lord Farquaad, but I think I crushed it.
You did crush it.
That's most things.
Okay? So the covalent bond is here. It's between two nonmetals. Within the polyatomic ion, you have covalent bonds. Between the cation and the anion, you have an ionic bond. So this has both ionic and covalent. This doesn't have a polyatomic ion in it, so it is covalent only because it's nonmetal, nonmetal, nonmetal. See the difference?
Yeah.
Okay. Now let's go the other way. I'm going to give you the name. You're going to write the formula. And then we're going to practice some of these. And then we're going to learn another type of naming after that's done. So let's do calcium sulfate. Okay? So here's the first name. Here's the last name. Let's put them together. Go ahead.
C and then SO4 and then -2.
Okay. So slow down 1 second. It's first of all it's Ca. Okay, for calcium. You know the sulfate is SO4. So I wrote down the first part, I wrote down the second part. Now you have to write in your charges, because the cation has a +2 charge, and the sulfate has a -2 charge. We're going to bring those charges down by crossing them. That's the crisscross method. So I'll write them in blue. This 2 comes down here. This 2 comes down here. The 2 subscripts that you put on the bottom need to be reduced to lowest whole number ratio. And so 2 and 2 are going to reduce to 1 and 1. And you're going to end up with CaSO4. You don't touch that 4. That 4 is part of that polyatomic ion.
Why do you have all the extra work with the 2s? They're just going to go back to 1s.
Because you need to... They don't always go back to 1s. Okay, let's look at this one. Okay, I put the charge on this lead. Lead has a 4, so that 4 is going to come down here. This 2 is going to come here. These 2 numbers, I could have actually, you know what, I could just do this. Let's do SO4. Same thing. Okay, same numbers. That 4 is going to come down here. That 2 is going to come down here. These are the only 2 numbers you can touch. Don't touch this one. That belongs to the polyatomic ion. Now, this 2 and this 4 get reduced to a 1 to a 2. So it ends up with a formula that looks like this. PB1, I'm not going to write the 1 in, SO4 2. Well, because there's 2 SO4s, I have to put that in parentheses. Because there's multiple of this SO4. Go ahead, keep talking it out loud.
Why isn't the 4 considered a subscript?
It is a subscript, but it's a subscript of this covalent section.
So once they're all together, is that...
Once you have a polyatomic ion, that polyatomic ion stays as a whole unit. Treat it as if it's just one thing. Okay? These are the subscripts you are going to tamper with. Only the ones on the outside. All right, let's go back to another one. Let's do aluminum nitrate. Okay, so I've got a first name, I got a last name. We write the pieces down. Aluminum, and what's nitrate?
NO2.
NO3. That's nitrite. NO3 is nitrate. Okay, just watch those. That's why I'm saying that, because nitrate and nitrite, they're similar. Same thing with sulfate and sulfite. Okay, after I get the 2 pieces written down, now you're going to write the charges in. Hello. She is, yes. Okay. No, it's okay. Is her for her phone? I don't. Did you get your phone, Emma? Oh, she lost her phone. That's what she told me she lost her phone. Okay, no, she's coming. She's on her way. Okay, bye. I'm on Mr. Mosca's office. Okay, so after we get those down, you're going to look up the charges. You know aluminum is a +3. The nitrate, you said, was a -1. Now we take those numbers, put a 3 down here and a 1 down here. I wrote them in different colors because those are the ones we can work with. I can't reduce them any further. And then I rewrite my formula, AlNO3. Notice I put the nitrate in parentheses because there are 3 of that nitrates. Okay? So every time you write an ionic formula, every time, from now until June, you have to write the first name and the last name and the charges and cross them down. I think I did a calcium already, but we'll do a calcium again. Calcium carbonate. Ooh, does anybody know what calcium carbonate is? It's chalk. Okay, calcium carbonate. What's the formula for calcium carbonate? Ca is the calcium. CO3 is the carbonate.
CO3.
Yep, CO3 is a carbonate. We got the pieces now. Now we got to do the whole crisscross thing. So calcium is a plus 2. Carbonate is a minus 2. We cross them down. If you can see that they're the same, then you know that you don't. But I'm going to do it for those of you who still need to see it. This 2 is coming down here. This 2 is coming down here. These need to be reduced to the lowest whole numbers, and so we end up with CaCO3. Give yourself a smiley face. Yippee. Okay? So, writing the formulas from the names, writing the names from the formulas for simple ionic compounds at this point. We did nothing complicated yet. You'll notice that I'm starting to run out of things because I'm only picking from group 1, group 2. Aluminum maybe I might be picking. Okay? Any element that only has one oxidation number, one charge, is what I've given you. In a few minutes, after we practice a little more of this, now we're going to go to the ones like in the transition metal area. You're going to see things like manganese. See how many choices you have? And iron has 2 choices, and nickel has 2 choices, and all that. So that's where we're going with this. Right now, the calcium only had 1 charge. The carbonate only had 1 charge. Cross them down. All right, now we'll go to our... Let me just shut this tape off for a little while. We'll come back to it later.
I feel like I
Okay,
know this.
step 2. So we know how to name. I just watched you name a whole bunch of stuff for ionic compounds. Now we're going to name things which are multiple oxidation numbers. And what I mean by that is if you look at your periodic tables, because you're going to have that in front of you, right? Here's your periodic table. Okay. I have been very careful to only pick elements that have 1 charge. So I was giving you things like sodium, sulfide, magnesium.
Bromine.
That's boron, but okay. It's not the same. Don't mess them up. All right, magnesium, chloride. I've been very careful. Now, aluminum only has 1. It has a plus 3, right? So I could say to you, aluminum chloride, and you would be able to write down aluminum, write down chlorine, put the charges in, and cross them down. That you remember, right? How many times did we have to cross the charges down?
You do it throughout the whole year.
The whole year. If you don't get this, you're going to have trouble. Okay? So
I didn't get it, and I did have trouble, so listen to her.
you have to know how to name your compounds. So now I'm going to give you iron and oxygen. And I want you to tell me the name of that. Iron oxide. Good. And then I'm going to give you Fe2O3. And I want you to give me the name of that. Iron oxide. However, these 2 compounds are different from each other. They're different because this one is made of 1 iron and 1 oxygen. This compound is made of 2 irons and 3 oxygens. They are totally different substances. So if I said to you, Olivia, please go to the chemical supply room and get me some iron oxide, which one are you going to bring me? You don't know. Okay? This iron oxide, FeO, has a subscript of 1 and 1, which means that their charges are going to be in a 1-to-1 ratio. If we look at iron, iron has 2 choices. It can either be a +2 or a +3. If we look at oxygen, there's only 1 choice. It's a -2. Which oxidation number needs to go here in order to give me the 1-to-1? The +2. Okay? So in order to make this FeO compound, which iron did I use? I used the one with the +2 charge. Okay? Now, when we name them, if there are multiple charges, And iron has multiple charges. It has Fe plus 2 and it has Fe plus 3. If there are multiple charges, we need to put a Roman numeral in parentheses right after the cation. Because the cation is what we're looking at. This iron, that's the positive, the cation. If we are using the iron with the plus 2 charge, then the Roman numeral that I'm going to put here is a 2. Because we are using the iron plus 2 ion. Now let's go over to this one. Which iron was used to make the Fe2O3? I'll give you a hint. It's not the 2. If we know that this oxygen is -2, what does this number need to be? +3. And so therefore, this iron that was used, I used the iron 3 to make this iron oxide. So we're going to put in parentheses right after the iron Roman numeral 3. Does everybody know their Roman numerals at least up to number 6?
Yeah.
Yes.
Okay, IV, VI. Okay? If you don't know the Roman numeral, just ask me. We're not testing you on whether you know the Roman numeral or not. We're testing you on whether you can tell me which ion is being used to make that compound. All right, let's try another one. Let's do Cu2O. Okay, first thing we do is we write down the 2 parts, just like we did before. We're going to write copper, and we're going to write oxide. The reason, Izzy, that it's ending in "ide" is because there are only 2 elements there. You see it? Okay. Now, we're going to go to our reference tables, our periodic table. We're going to look at copper. Does it have multiple choices? Does it have more than one copper? Yes, we have a copper 1 and we have a copper 2. So because there are multiples there, we're going to put parentheses and we're going to say to ourselves, which of those coppers was used to make this Cu2O? Okay?
Copper 1.
How do you know it's copper 1?
Because there has to be 2 on the oxygen.
There has to be a -2 on the oxygen, which means that there had to be a +1 on the copper. Now, some people can't see that, so what I tell you to do is I tell you to write them. Do copper +1 and oxygen -2, cross them down just like we did before, and see, does this give us what we're looking for? And it does. So this is copper 1 oxide. Copper's a big one. They love to use copper. Let's do nickel. Let's do nickel phosphate. Okay, so I'm going to write nickel phosphate down so that we can remember what I said. And let's see. Actually, it's I'm writing the name, so I have to give you the number. Let's do nickel 2 phosphate. And I want you to write the formula, not the name. Okay? So I'm going to write the 2 pieces down. Nickel and phosphate. What's the charge on the nickel? When you look here, nickel has 2 choices, right? Which one am I using? The +2. Okay, and for phosphate, we're going to use PO4 with a negative, not 2, -3. Okay, we're going to get that right from table E. Let me move this out of my way so I can find it. Okay, so we'll go back. You know what? Let's duplicate this. Duplicate. Let's go to table E. Let's find phosphate. Here's phosphate. You see how it has a -3 on it? Okay? There's only one choice there, which is good news. Now we have to cross them down, so this becomes a 3, this becomes a 2. Can I reduce the 3 and the 2? Nope. So we end up with Ni3PO4 2. Am I done? Yeah, there's multiple of this, so I'm going to put it in parentheses. Don't forget, if there's more than one polyatomic ion, you have to put that in parentheses. Okay? Because otherwise it looks like there's 42 oxygens, and we don't have 42 oxygens. We have 2 PO4s. It really looks like this. We got nickel with a +2 charge, another nickel with a +2 charge, and another nickel with a +2 charge. And we have a PO4 with a -3 charge, and another PO4 with a -3 charge. And so this is really what we're dealing with. And you can see that the charges are all going to add up to 0. Okay? That's what that is. That's what that means. 3 nickels with a +2, 2 phosphates with a -3. Okay, let's try another one. Let's do... I got one. I got a good one. Manganese 7 VII oxide. That's a 7. 5, 6, 7. Manganese 7 oxide.
What's like the thing for manganese?
Mn. Manganese is Mn.
Okay.
It's number 25. I told you it was manganese 7. So that's what we're using. Okay. Well, Will, you got an answer for me? Go. Okay, Mn2O7. How'd we do out there? Easy peasy? All right, let's go the other way. Let's go MnO2. Give me the name of it. You know it's manganese and you know it's oxygen. What's the name of it? You know it's manganese.
2 oxide.
Nope, it's not 2. You know it needs a Roman numeral. You got to figure out what Roman numeral it needs. It's not 2. Who said that? Why? Yeah, okay. That doesn't sit right with me. Why is it 4? Yes, because the oxygen has a -2. That's going to give you -4 right there, right? Yeah. So if you have 1, you needed a +4 here. So when that 2 and the 4 canceled or came down, the 2 was here and the 4 was here, which reduced to 1 and 2. Be careful with that. So this is manganese 4 oxide. How about NiPO4? NiPO4. What's the name of that guy? Nickel, yes. Phosphate, yes. Does it need a Roman numeral? Does nickel have more than one option? Yes, so you have to have parentheses there. And you've got to give me a, put your fingers up again. No. You got to give me a number that's going to make me nickel NiPO4. What's the charge on the PO4? It's a -3, right? So what number has to go here that's going to give me a 1-to-1 ratio?
Plus 3.
3. Nickel 3 phosphate. How about MgSO4? I'm playing games with you now. Playing games. Think. Magnesium sulfate. Does it need a Roman numeral? Why not? Magnesium only has one charge. So whenever you're writing the names now, you've got to go back and look. Does it need a Roman numeral? Sometimes it will. Sometimes it won't. CR. No. CrPO42. CrPO42. Cr is chromium. I'm going to give you some to practice on your own in a few minutes. Chromium. What's PO4?
6.
Okay, just hold on a second, Kevin. Let them think. Okay. Does chromium need a Roman numeral? Yes. What Roman numeral you want me to put there? 6. Because phosphate's a -3. Because when I bring that 6 down and I bring that 3 down, it's going to reduce to 1 to 2. You guys got this? Okay. This is called naming with the stock system. You don't need to remember that. I'm just putting it out there that it has a name. When we say naming with the stock system, it means you are going to now tell me the charge on the cation if you have multiple charges on your metal. You don't ever put a Roman numeral for the anion. It's only for the cation. All right, let me shut this off. We don't need this anymore.